hear me? It's amazing. Everything is working. Well, now everything's going to break down. I've just jinxed myself. Okay, well, I decided since this is a career fair, I would talk to you about a career in science teaching and learning. Many of you are contemplating careers in academic research, right? And I just want to remind you that teaching is part of that job. And nobody ever thinks about it. At least when I was a student, never thought about the fact that I would be teaching someday. And I'd never thought about how best to teach and how students learn. It just was not part of my universe. So I don't know if it's part of your universe, but I thought I would make it so. So first I'm going to show you a video that I made at the request of a fellow Swarthmore person who was encouraging me to tell people about my life in hopes that I would encourage other people to follow a career. So this is this video. Looking back over my career, I've come a long way for someone who didn't quite know where she was going. I was always a goody-goody. I loved to learn and to help others learn. In third grade, my teacher would ask me to sit next to people who were having trouble and work with them. After graduation from high school, I went to Antioch College, a work-study school where I thought I could work my way through. I started out studying science, but was told that I was a people person, so I tried jobs, such as a nurse's aide, too independent, and a boarding school infirmary supervisor. I was not strict enough. Then I took analytical chemistry and messed up a titration. Shit! What a wonderful thing it is to curse. I was hooked on chemistry. It was fun. I really loved working in the lab. It reminded me of the pleasure I had as a child in the kitchen, mixing baking soda and vinegar and understanding how the atoms rearrange themselves to produce carbon dioxide gas. But is that a career? I applied for a Woodrow Wilson Fellowship aimed at encouraging people to go into college teaching. At the interview, I was asked what DNA was. You mean the double helix? I said while waving my hands in spirals. I had never studied DNA, never had a biology course, but I'd been working in a biochemistry lab, so I got the fellowship. But Brandeis offered me $200 more per year, so I turned down the Wilson Fellowship. Honors? Who cared? Brandeis cared. They made me scramble to get it back. Brandeis did turn out to be a very supportive environment. I met my husband, who was in grad school at Harvard, in my first year there. I was several months pregnant when I defended my PhD thesis. My advisor jokingly mentioned the possibility of an abortion, since it was too late for birth control. My husband has always been enormously supportive of my career. It would never have occurred to him to have a stay-at-home wife, and I can't imagine that I would be a good homemaker. Of course, I had to hire someone to help take care of my household, and I was glad of the support. If I had had to stay home, I would have gone crazy. Now, I have 2 microwaves, one for each lean cuisine. I was a faculty member at Swarthmore College for 26 years, but I don't think of myself as a master teacher. I think of myself as a master student who loves to learn and loves to help others to learn. With my husband, I've published 2 biochemistry textbooks that have become standards in the field. We also co-edit the journal Biochemistry and Molecular Biology Education. This coming April, we will be co-recipients of an award for exemplary contributions to education from the American Society for Biochemistry and Molecular Biology. I am just continuing what I started in 3rd grade, and I'm still having fun. Well, now you know my whole life. That was 4 minutes, my life. Woof. So I've had a successful career in college teaching, but as the video said, I've also had a wonderful career as a wife, mother, and grandmother. Those were my grandchildren at the end. And I wanted to point that out to those women in the audience who might be wondering or worrying about how to fit everything together. It works. Just go for it. So if you're thinking of a career in academic research, it's important to think about the teaching responsibility as well. The video showed you that I had applied for a fellowship that encouraged people in college teaching. Well, I only applied for the fellowship for the money, right? College teaching was just not on my horizon at the time. And in fact, when I even suggested it to my husband, he looked at me like I was crazy. He said, "You don't want to teach." No, but teaching turned out to be a very exciting career for me. And I want you to think about teaching, because academic research does mean teaching as well. So once I chose college teaching as a career, how did I proceed? What did I do? There's no educational preparation required. High school, you have to get certified. Elementary school, you have to get certified. College, nobody cares. You don't have to have any kind of background at all. So there we are. I never got any training. I didn't know what I was doing. And I only thought about creating interesting and entertaining lecture presentations of important information. I was a content specialist, and I still think of myself as a content specialist. I told students what to learn, and they went home and they studied the material. That's what I thought teaching was all about. You present the material, students take notes, write it down, go home, study. And as I said before, content was the most important aspect of my teaching. I thought that students would learn what biochemistry was by working in the laboratory. And I still think that that's really the way to go, but I'll tell you some other things as well. So when I was teaching, I had a lot of laboratory to go with the courses, and I made laboratory exercises that were as close to research experiences as I could get them. And I tried to coordinate the content of my lectures with the laboratory so that students could experience a bit of what they were studying. For those of you going into an active research endeavor, I want you to know that it's a reciprocal relationship. You're going to have to teach, but it's very important for the students to have that experience in research, because research experience, as you know now as students, is the best preparation that you can have for further work in biochemistry or molecular biology. So that was all during my career, and it may well be your educational experience as well. But in recent years, things have been changing. And Don and I became co-editors of BAMBED, the Biochemistry and Molecular Biology Education Journal. Suddenly the word learning got into my vocabulary, as well as thoughts of teaching. How best do students learn biochemistry? I'm still not sure. Now, this talk is going to be mostly questions and no answers, but the question is, do students learn what we actually think we're teaching? and does teaching with lectures promote student learning? And are there other techniques that might be used that I, when I was teaching, never even thought about? And what the kinds of papers that we've been getting in biochemistry and molecular biology education have been showing me is that there are techniques called interactive engagement techniques, and that they promote learning. And what I mean by interactive engagement techniques are problem-based learning, process-oriented guided inquiry learning, or POGIL. Everybody talks about POGIL these days in the biochemistry education community. There's also case-based learning, inquiry or discovery-based learning, cooperative, collaborative learning, and there's the use now of clickers in large lecture classes. How many people have used clickers in classes? No, so you haven't seen them yet. That's become almost a rage in the United States, at any rate, in large lecture classes. I'm going to, in a few minutes, tell you a little bit more, or have you experienced a little bit of this process-oriented guided inquiry learning and the use of clickers. Not that I have any clickers, but I will tell you more about them anyway. So the thing that happens when you change from lecture to interactive engagement is that a teacher becomes a facilitator instead of a lecturer. I'm right now the sage on the stage, right? If I go to an interactive engagement process, I become the guide on the side. I become a facilitator. And hopefully students take more responsibility for their own learning, and the student teaches herself. That's the concept of interactive engagement. You're sitting there, instead of absorbing what I tell you in class, you're interacting with each other, and you're trying to figure things out. So there are problems with interactive engagement techniques. They're labor intensive. When I was towards the end of my teaching career when I first heard about them, and I thought I would try. And it was such a hard job to get anything to work that I decided to retire instead from teaching. I have not disappeared, but anyway. So they're very labor intensive. Large classes are difficult to engage, and you can't cover as much material as you can in lectures. I can just, I can go through these slides. I could spill so much information at you. I would be so proud of myself. I have conveyed so much content. Did you absorb any of it? That's the problem. So you can't cover as much material as in lectures, but supposedly retention is much better because the students get to interact and think about the things in class. I never thought about anything when I was a student, when I was in class. I was too busy taking notes. So anyway, people are now doing research. There's now a whole section of biochemistry research which is in education. How do students learn biochemistry? There's a whole education research community that's outside of biochemistry. And there's not very much communication between biochemists and education researchers. But now biochemists themselves are beginning to do education research. And when a biochemist does education research, somehow other biochemists will listen a little bit better. So they're doing research on effective teaching, learning, and assessment methods. And where can we find this scholarly work? Well, of course, Biochemistry and Molecular Biology Education, our journal. So there are some helpful articles, and I may be an editor of this journal, but I'm also a reader of this journal, and I am learning more and more about the new techniques that are being used for teaching. Now that I've retired from teaching, right, I'm learning more and more about how teaching happens. And I've mentioned this POGIL, process-oriented guided inquiry learning. And we can use it in large classes. And there's an article by Cheryl Bailey, Vicki Minderhout, and Jenny Lorcher talking about large lecture halls and using this concept. And there's another article about using clickers. What clickers are, since nobody has used them, are devices that every student gets when they come into the classroom, and they're somehow connected wirelessly to a computer program in the professor's computer that